Welcome to part 2 of Friday's lecture on benzene in the aromatic series. I'm going to start to talk about some naming now. Naming the benzene series, there's not nearly as many rules, and they seem to be a lot more loose in terms of order things can go in and numbering and that kind of thing. So on the one hand, that's great because it's just not as stringent, but it can be a bad thing because you never really know quite for sure if you're doing it right, but you probably are. So it can be a good or a bad thing. If you have a mono-substituted benzene ring, that means just one substituent on there. So instead of a hydrogen, you have something else like a methyl group or something like that. A lot of those have what are called singular names, which are kind of like common names. So I don't want you to know all the singular names because there's a ton, but there are some singular ones that I want you to know. So those of you who are not here today, I had a worksheet or a handout that has these on there. We're just going to write in the names. So first is bromobenzene. This could also be chlorobenzene if this was a Cl. This could be iodobenzene, or this could be fluorobenzene. So notice there's no number there. It's just the stemo of the substituent with the parent chain name benzene. Remember, you could just as well have your circle in the middle there of your benzene ring. So there's one, mono-substituent. So there's just one in place of a hydrogen, and notice we don't draw the rest of the hydrogens. Okay, bromobenzene, we've got nitrobenzene. The nitro group is this NO2 group right here, nitro. We have toluene. Toluene is when I have a methyl substituent. It gets the common name toluene. Phenol with a hydroxyl group. Benzoic acid, this group up here, the COOH, actually looks like a C double bond O and an OH group. This hydrogen can be lost, making it an acid, a hydrogen donor, hydrogen ion donor. Benzaldehyde, this one might not be on your sheet actually, you might have to write this one in. The aldehyde group, and we're going to start talking about functional groups a lot more here in the very near future. The aldehyde is a lot like the acid group, except for there's no O. So that H is not going to be lost. It's going to stay connected. So it's not an acid. Benzaldehyde. And then we have aniline. That is with an amino group, an NH2, as opposed to a nitro group. And I believe that's all the ones that there are. I'm just going to go back because there's one more I want you to put in here, and that is the xylene. And xylene is when I have two methyl groups, and this is a concept for later. They don't have to necessarily be right next to each other, adjacent like that. They can be 1 and 3, 1 and 4, and we have some special names for those as well. So that's a xylene. So this is for 8 that I want you to be familiar with. They won't be familiar right away, but we'll get used to using them. So those are called the singular names. Okay, so let's talk about some designations for two substituents. So one way that we can designate these substituents is if they are in the 1-2 position. So for example, let's say that I have this benzene right here. That would be bromobenzene, but let's say I have, whoops, 1-2 would not be right there. 1-2 would be 1-2. So now I have two bromines and they're in the 1-2 position. Instead of saying 1,2 dibromobenzene, we can call this the ortho position or just the O position. So this would be ortho dibromobenzene. So the ortho just saying that they are adjacent to each other. So that BR could actually be on this side too, 1,2 going around to the left. You can also do it with a singular name. So let's say that I had phenol, should be the OH hydroxy group, and we'll stick with bromine, and they are adjacent to each other. So they are still in the ortho position, but this time I'm going to use my singular name as being phenol, and I'm going to call it ortho, or even just O, bromo, phenol. So that's just saying my bromo is in the ortho position of the phenol compound. Does So that's one way we can do it, adjacent. Then we have meta, and meta is the same idea except for it's in the 1-3 position. So I might have something like toluene, and let's see what's interesting there. Let's put a, oh gee golly, let's put an ethyl there. So these two are in the meta position, the 1-3 position. So I'm going to use my singular name toluene, and I'm going to say meta ethyl toluene. And meta is saying it's in the 1-3, and then toluene just assuming it's in the 1 position. Finally, if they're in the 1-4 position, that's para. Go back to our xylene. Remember, xylene is if I already have 2 substituents. So para-xylene would be when those 2 methyl groups are directly across from each other. We could also do something like this, where we had toluene and maybe like an iodine down here. So that would be para, or you could even do just P, para-iodo-toluene. So just showing the positions on the benzene ring. Okay, if you've got 3 substituents or more, you're back to numbering with your lowest possible combination. So back to kind of the rules we've been following before. And you have the parent name benzene now. And sometimes these incorporate the singular names. So if you see a singular name, just you know what that means already. And then sometimes you might add a little bit more to it. My favorite is this guy right here. So you got toluene, and then there's 3 nitro groups attached. So there's 4 substituents in all. So we would use the singular name as kind of our parent chain, toluene. And we would say 2, 3, 5, because if it's toluene, we're going to assume that that's in the 1 position. And that would be trinitro toluene. And that is where TNT comes from. So that molecule is trinitrotoluene is TNT. So anyways, that's just a good example. But if you don't really have a singular name and you just have, 3 bromines and a chlorine or something, you would just go with the lowest number combination possible, like we have been. That is the most terrible looking benzene ring ever. Okay. Sometimes benzene can be a substituent if it's not part of the parent chain. So here's an example right here of how benzene is a substituent because they have named the unsaturated hydrocarbon over here as the parent chain. So propene is my parent chain, and then off of the first carbon is a phenyl, and that is a benzene directly attached to the parent chain. So that little red squiggly is showing a direct attachment to my parent chain. So we've got a 2-methyl, 1-phenyl propene. Notice that there's not a 1 before propene because really if the multiple bond takes precedence, it should always be on the 1. A benzyl group is a little bit different, just subtly different than a phenyl group as a substituent. And that is when it's not directly attached, but there's a CH2 that's directly attached. Now in this case right here, this is not great. This is not a parent chain per se. This is just a bromine. But see how that's the benzyl and then bromide. So again, we're not sticking to like super strict rules of naming. You might see something where like you have a really big long parent chain, let's say like C5H11, and then maybe you've got your benzyl group on there. That would be, well, I guess I'm numbering from the right now. Yeah, let's do that. So I've got 1, 2, 3, 4, 9 carbons, and this is my benzyl substituent. So the CH2 is connected to the chain, but then you've got your benzene ring off of the CH2. So that's benzyl. So again, don't freak out about the aromatics because their rules for naming are pretty fast and loose, and it's not worth getting stressed over. Usually you can figure out what you're dealing with if you know some of these singular names. So take some time. This is your handout to understand these names. I'll let you use it for a while until you get used to them. But don't worry about all of the UPAC naming for these as much as we have with our other hydrocarbons. So that's it. I hope you enjoyed it. Have a really good day and a really good weekend, and I'll see you later.